Where to put my cooker?
Okay. So,
We need the
I'm sorry, what?
the new notice.
You weren't listening.
I'm sorry.
Thank you, Brian. All right, so as a practice here, let's see if you can do a product rule yet. Now, one of the other things that happens when you're doing these problems is that, and I've talked about this quite a bit, there are multiple ways to take these derivatives. So in this problem in particular, you can use the product rule, or you can multiply it out. It's up to you. I don't care what method you want to use, but take that derivative, please.
Which one are you? Well, there's two of them.
Yeah.
How did I not get a box?
I
That one back there doesn't work. There's one there that doesn't work. This one does work. That one works. There's one up there that works. You could sit right underneath the board. That wouldn't be awkward at all.
That would be really awful, actually.
No, it'd be fine.
Make her present. She just knows. Listen, I'll survive.
You okay?
I'm good.
What percent are you at?
It's my stylus, so I'm gonna use my finger.
Easy. You got it.
I'll pull through.
Do you need a stylus?
I'm a fighter. No, I'm good.
Sure.
Yeah, but like that's good.
Here.
I mean, it's a little bit disruptive. You. Oh my goodness, this is fantastic.
I saw you writing.
Thank you.
Earlier this time.
Oh, that's
One of your teammates got hit in the NCH parking lot.
Yeah.
Somebody backed into her car and then took off. Okay.
Who?
I don't know who it is. I don't know. But she had one of your big. I mean, I couldn't have hit her with my car because I couldn't. She was so obvious that she stopped like right in the middle of the road. I was driving through the NCH parking lot. There's a Jeep, like a brownish Jeep.
Oh, that was Reese. That's what she was saying to her. Oh, it's not good.
Yeah. Somebody just backed into her in the parking lot and took off. I'm like, okay, well, they're right over there.
Oh.
All right, Max, catch. It's all you, buddy.
All right.
We got the same. Before Max starts working, what degree is that equation? Sorry, it's not an equation. What degree is that expression? Shh. What degree is that expression? It's a fourth degree equation. So therefore, if Max did the work correctly, what degree should the derivative be? Third. Good.
Do you want me to do all the work or just the answer?
We'd like to see the work.
Oh, sounds good.
Down at the bottom there. See a little pen
Oh,
there?
yeah.
Pick your color. You want red, okay?
Yeah, that's fine.
All right, go ahead.
Alright. How do you...
Oh, you don't mind? Mine never works. I mean, I can hear it.
Okay, so it appears that appears that Max chose to use the product rule. Yes?
Yep.
Derivative of the first times the second plus the first times the derivative of the second. Multiply that out. Let's talk a little bit. Let me get super picky here. There should be a y here. Because once you start taking the derivative of this, then you're talking about the dy dx represents the derivative. Okay. Do you agree with his answer?
Yep.
Okay, good. I didn't do the work, so we'll assume that he did it correctly. Well done, Max. Let's give it up for Max. Did anybody multiply it out? Okay. Same answer? Beautiful. Okay. Today we're going to talk about the chain rule. This is big. What does the chain rule do for us? It allows us, oh, hold on, let me do this. We're going to take the derivative of composite functions, which will be instrumental in doing one thing for you, which I try to do as much as possible. As I mentioned earlier, I don't like the quotient rule. I avoid it whenever possible, and one of the ways I avoid it is by using the chain rule. I'll explain what I mean in a minute. Yeah, we're going to simplify a little bit today, but not too much. We're going to look at some trig functions, and you should be able to recite the state capitals. No? No, I can't do it either.
Maybe half.
Okay, so let's suppose this is our function. Based on what we currently know, we would have to do that as a quotient rule, yes? Now, the interesting thing about the quotient rule with this problem is what's the derivative of the numerator? 0, so that term disappears. Is it doable with the quotient rule? Yes, but what I like to do instead, since I loathe the quotient rule, is I would write it like that. Now, at this point in time, you don't know how to take the derivative of that because we haven't talked about the chain rule, but we're going to talk about it in a second. Looking at what I wrote in red, how many functions is that? I'm going to let the question hang there and not explain it until after you give me some answers.
1.
Could be 1. It's not.
2.
2. What are they?
2x minus 7.
That's one of them. That works really well on the audio.
Is that reciprocal?
Reciprocal function.
Yeah.
Yeah. Yeah. Which one's on the outside?
The reciprocal function.
Good. Okay. That's key to succeeding with the chain rule, is recognizing that, yes, technically speaking, that is one function. It's f of x. But it's made up of 2 other functions. The linear function on the inside and the reciprocal function, or being raised to the -1 power, on the outside. Okay? You all see that, yes? All right, I'm going to come back to this and show you how to do it. Obviously, well, I'll do it quickly. You can do it as a quotient rule. 2x minus 7 quantity squared on the bottom, bring that up to the top, times the derivative of the numerator, which is 0 minus big honk in bracket, 2 times 1, and get -2 over 2x minus 7 quantity squared. Okay, fine. There it is. Quotient rule. It's not horrible, but it's doable. I don't like it. I'll show you how to do it the other way in a little bit. So let's move on to the chain rule. This is great. I have 2 ways to do it. I could do it, like I said, in the red, which I'll show you later, or you could do it as a quotient rule in the blue. But what happens when I got that? Does anybody want to multiply that out 10 times?
No.
The answer is no. If the answer is yes, there's something wrong with you.
Danny's not here.
Yeah, Danny's not here. Way to throw a guy under the bus who's not even here to defend himself. But he probably would want to multiply it out. We agree with that, yeah?
Yeah.
Okay. I don't want to multiply it out. You don't want to multiply it out. We'll ignore the fact that Danny would want to multiply it out. And we want to be able to solve that using the chain rule. So when we're learning the chain rule, I'm going to go through this process over and over again to the point where you're going to get tired of listening to it, but hopefully it will burn into your brain. And it goes something like this. How many functions? No. No. 2. What are they?
Oh. Wait, mental math.
I understand. Doesn't require any math.
I'm trying to split the
No. Just tell me what the functions are.
x squared minus 3x plus 7.
Good, that's one function.
Thank you.
The quadratic on the inside, what's the other function?
It can't be a function. To the 10th is not.
Yeah, that's a function. Raising something to the 10th power is a function. Yes.
Oh, I understand.
Okay, good. Which one's on the outside? Raising to the 10th or the quadratic? 10. Okay, so we've got that, yes?
Yeah.
So the chain rule works like this. I'm going to pretend, and I'm just going to show you this to help understand the chain rule. You're not going to solve chain rule problems like this. But instead of writing it out as a quadratic, what if we just called that U? No. What if we just called that Z?
Oh, Z.
This is the same thing as Z to the 10th. Can you take the derivative of Z to the 10th?
Yeah.
What is it?
10 to the 9.
Anything difficult about that?
No, sir.
No. Good. Okay, so if you can do that, recognize how many functions you have. Recognize what they are and recognize which one's on the outside, then you're good to go. We always work from the outside in. So we're going to take the derivative of the outside function. I'm not going to bother with this substitution because we're all fairly bright. I'm just going to take the derivative of a function raised to the 10th power. So what you told me is so g prime of x would be equal to 10 times whatever that thing is to the 9th power. Are we good there?
You have to keep doing it until like the 8th.
That's a great question. I'll answer your question in a second. How many functions were there?
2.
2. So, because it's a chain rule, what we then have to do is chain on, that's why it's called the chain rule, chain on something on the back end of that function. What we have to chain on is the derivative of the inside function now. Okay. Now, Andrew asked a question, well then do you have to do it for the 8th and the 7th and no. Because if I continue taking the derivative of that, what's going to happen? Right. What's the derivative of 2x minus 3? 2. What's the derivative of 2? 0. Therefore, the derivative would be 0, and it's not. That's the single most common mistake that people make with chain rules. They chain too many times. What's that? In this case, you only chain once. But there is a rule on how many times you chain, and the rule is you chain on one less time than the number of functions, and that's why you need to be able to identify the functions. Okay, so we're done there. That's it. That's the derivative. There were 2 functions. We chained on once. We're done. Okay. Now, what is the chain rule doing? If you didn't recognize it, g of x and f of x are composite functions. They're a function within a function. So if I go back to what I did on g of x, I can now take the derivative of f of x. A function raised to the negative 1 power is negative 1 times that function raised to the negative 2 power, and chain on the derivative, 2 functions, 1 chain, 2. Simplify that, negative 2 over 2x minus 7 raised to the 2nd power. Oh, look, same. So in this case, chain rule, fine. Quotient rule, fine. This case, chain rule, good. Multiply out, bad.
Yeah.
So you kind of have to know the chain rule there, unless you're Danny. I wonder if he's actually going to watch the video because he's not here.
He's
Nelson,
he does.
He is?
He does.
Beautiful. Hi, Danny. Yes, Nelson.
Let's go back one slide really quick. Thank you so much.
No problem.
I was trying to get that. Do you get it? No. No, I'm going to tell you to go over and explain it. I did, but I didn't.
The slideshow is loaded with tons of examples.
Okay.
Okay? So again, it's allowing us to take the derivative of composite functions. Functions within functions. The left-hand column are all functions that you know how to take the derivative of up to this point because they are single functions. Okay, x squared plus 1, sine of x, 3x plus 2, x plus tangent x. Remember, simplifying things with pluses and minuses doesn't generate another function. The right-hand column, all of a sudden we start to get composite functions. Okay, that's x squared plus 1 put into the square root function. The sine of 6x, two functions, 6x put into the sine function. We saw something like 3x plus 2 all to the 5th power. And then the last one, of course, we've got a composite function with the x squared into the tangent function. There's the fancy schmancy chain rule based on two functions, f and g. We start with a composite function. This is something you're going to want to write down because you'll recall the problems that we did where I had h of x is equal to f of x times g of x. And then I asked you to figure out what h prime of x is based on that. The same is going to happen with chain rule, sorry. You're going to have a composite function in terms of f and g or k and l or whatever it is you're dealing with. And you're going to have to use the chain rule to find that derivative. Why is there a red onion in the lower right-hand corner? There's layers, like an onion. You're going to work from the outside in on every one of these problems. Which again is why it's important that you be able to identify how many functions are make it up, which one's on the outside, which one's on the inside. Because that will help you solve the problem. Okay. Get rid of this. All right. All right, so we'll watch the video in a second. I mentioned this already, but I'll repeat it again. You chain on one less time than the number of functions. If you have an equation that has 3 functions, you're going to chain twice. You have 2 functions, you chain once. You have 7 functions, you chain 6 times. That has to be followed every single time. Otherwise, as we saw in the previous example, if you just keep chaining, you're eventually going to get to 0 and it negates the whole thing.
And rescue a princess just so Farquhar to get you back to swamp, which you only don't have because you filled it full of fish in the first place. Is that about right?
You know what? Maybe there's a good reason donkeys shouldn't talk.
I don't get it, Shrek. Why don't you just pull some of that ogre stuff on him? You know, rob him, lay siege to his fortress, crack his bones to make his bread. You know the whole ogre trick.
Oh, I know what. Maybe I could have decapitated an entire village and put their heads on a plate, got a knife, cut open their spleen and drank their fluids. Does that sound good to you?
No, not really, no.
For your information, there's a lot more to ogres than people think.
Example?
Example? Okay, ogres are like onions.
They stink?
Yes. No.
Or they make you cry?
No.
Oh, you leave them out in the sun, they get all brown, start sprouting little white heads.
No. Layers. Onions have layers. Ogres have layers. Onions have layers? You get it. We both have layers.
Just my excuse to put a Shrek clip into a slideshow. Chain rules and ogres.
Is that all on the recording?
Yeah. Which means it'll probably get bumped off of YouTube because it's a copyright infringement. But we'll see what happens. I'll live on the edge. Daniel might not be able to watch that. Okay, so let's practice a little bit. How many functions?
2.
2. How many chains?
1.
1. Good. Take the derivative. While you're working, I'm going to make a note here. Notice that this is also that. So as much as I dislike the quotient rule and like the chain rule, you may find yourself liking the quotient rule and disliking the chain rule. I don't know why. But in this case, you could convert it into a quotient rule and solve it that way. But I would encourage you at this point, since we're dealing with chain rule, to do it as a chain rule problem. We'll be fair.
Well, I mean, it's the same thing.
Nadia, you're up.
You don't go farther. We don't saw you farther. I mean, this unit's pretty straightforward.
Oh my gosh, that's not an equal sign.
Alright. How'd she do? Yes? Quiet. How'd she do?
Good.
Great. Now, if you're feeling all fancies in your panties, you could have written it as -4 times, right? But this is good because we can see how you took the derivative of the first function and it chained down the derivative of the inside function. Mia, you had a question?
If it was like 2x minus 3 to the first power, would that be one function or two functions?
Technically, it would be one function because we don't care about anything to the first power. We don't really treat that as a separate function. It would just 2x minus 3. Okay, good. We're all good on this one, yeah? Okay, good. Baby steps before we jump into something a little bit scarier. All right. 2 functions. 2 chains. Sorry, 2 functions, 1 chain.
You gave us the answer.
And again, yeah, I know.
Oh, okay.
And again, notice that I did not multiply this out because I'm not going to take something and raise it to the 3rd power. In fact, I'm not going to multiply anything out. You might be tempted. Oh, actually, let's talk about some bad math. For some reason, people think this is okay, that you bring that 4 in here. You all realize that's bad math, yes? Because of this cube.
Yeah.
Could I bring the 4 in here?
Yeah.
Yes. Okay, good. Just wanted to make sure that we're all on the same page. I knew you guys were okay, but, you know, Danny's not here and he was trying to make that mistake. Danny, that's for you, buddy.
No, I swear he said he was going to watch the video.
No, because he watched the last one and he said that he did.
He's going to be do like the past.
Well, he's not here. He should know
I
watch
didn't
the
agree.
video. I'm not going to teach him a private lesson. He's going to do some work.
Danny heard him watching this.
Yeah, he doesn't have to.
All right, solve that one.
Follow my YouTube, be subscribed. Doesn't matter if you miss this. Like take the AP test now. English talking about stuff
He's probably going to get a notification when I post the video. He's driving his car watching.
So get that little bell, get the notification
I watched one math YouTube video on YouTube, and now all I get is math videos right now.
They did like SAT prep videos and now.
Yes.
Nobody should say anything. We'll just see what his reaction is.
Fair enough.
Mr. Rudy, how many subscribers do you have?
I'm sorry?
How many subscribers do you have? Does Danny win?
What's your most viewed video?
I never go back and look at that crap.
Because
Mrs. Hernandez, she has like 600K on one. Because like,
You have 60 subscribers.
60?
In case you didn't know, kind of a big deal. Your most, 1.6K views.
How many?
1.6K views.
7 years ago.
Why is what's wrong with doing after oral surgery?
I don't know what you're watching. You're recommending.
No, this is.
Let's go. Team player. Do it for Danny. Danny. I'll keep your seat warm.
I got it. Very similar.
Let's do it.
he's watching.
Come on, do it.
Do it for Danny.
What do you guys?
You're good. The 4 belongs there.
Yeah, this was pretty simple.
Why is it writing like that?
What's that last business?
Parallel resisting motion.
going on, man?
Yeah, that's too different. Like,
Why is it covered? 12x.
It's cursive math.
Why are you doing like a breast cancer ribbon? Got it. Okay, that's an X. Okay, thanks. Any problem?
I still can't read it.
Any problem?
I think I can write that on my like right hand.
It does like stick.
I love
Alright. Enough. Trig functions get a little nasty. The reason they get nasty is people confuse these two things.
Huh? Is it not the same thing?
Oh.
What is the difference, Maria, between each of those three things? No, not you, Maria. Other Maria, sorry. I keep making a mistake.
Sorry.
It's okay.
What is sine squared of x plus theta?
All right, so back up. In the first one on the left, what's being squared?
Sine.
Just sine?
Sine squared.
No. Sine squared is not being squared.
Just sine is being squared.
No.
No.
You can't just square sine. No. All right, let's move to the middle one. What's being squared?
Sine x.
No. Okay, let's move to the right one. What's being squared? Good, good, okay. All right, so we got the right one under control. In the right expression, sine x is being squared. What's being squared in the middle one? Just the x. This is the same thing as that. Okay? What's being squared in the first one?
The y value.
What is it? Sine x. This and this are the same thing. Okay? Also, let's talk some bad math. You cannot just bring things into a sine function all willy-nilly. Also, this makes no sense. You have to take the sine of something. Okay, I have people do this all the time. Okay, that's wrong on so many levels that I don't even want to address it. Okay, don't make those mistakes. So let's look at some chain rule problems. You don't need to write this down. You know this already. Sine of u is two functions. Sine is one, u is the other. Which one's on the outside? Which one's the outer layer of the onion?
U.
Sine or u?
U. U.
The sine is on the outside, yes. U is on the inside, so you do the sine first. Sarah! Sorry, oh, go ahead. Finish. I didn't know you were talking about it. Go ahead.
Math and math make you
Then go ahead and finish, then I'll ask you.
But he can write his name.
so bad. It's still
Good? How many functions? Shh. Three. Outstanding. What are they?
4x to the bed.
That's one.
Sine
That's two.
and
Raise to the power of two. Okay, last question, then I'll leave you alone. How many chains?
2.
Two. I lied. One more question. Which one's on the outside? What's the outer layer of the onion? That's two functions. Which function is on the outside? The sine, the squared, or the 4x to the fifth power?
The square.
The squared. Good. Okay. If it helps you, this is the same thing as this. functions. 2 chains. What's the next layer of the onion? The sine or the 4x to the 5th? Nope. Well, you had 50-50 chance. Three functions. The outer function is a squared term. Therefore, I brought the 2 down and reduced the power by 1. It doesn't matter what the function is. That's how you take the derivative of something raised to the second power. The second layer of the onion is the sine function. The derivative of the sine function is the cosine of whatever that thing is. It happens to be 4x to the 5th. The second chain, then, is the derivative of 4x to the 5th, which is 20x to the 4th. Done. Okay. This is going to be fun, right? Anybody fan?
Yeah.
Oh, can we have a moment of silence for Coolio? I just found out yesterday. Yeah, I found out last night. I didn't, I wasn't up on current events. That's Coolio ringing a bell from heaven. This
That makes sense.
is up to this point all the derivatives we've done.
Interesting.
Which ones have I done?
Yeah, I am. It's out.
Questions? Okay, we're done.